How dynamo is formed. A simple dynamo contains two main parts. First one is a set of magnets, to create strong magnetic field. And second part is a closed electric wire, of rectangular shape. It is called the armature of the dynamo. Armature may be of multifold wire, but, for simplicity, we are considering a single-fold armature. The armature can rotate about an axis, inside the magnets. Magnetic field is always pointed from the North Pole, to the south. These particles are showing you the direction of the magnetic field. How dynamo works. If, by some external force, the armature starts rotating about the axis, an alternating current generates in it. It is called the induced current. Where this current comes from? Actually, when a conductor moves inside a magnetic field, an electromotive force or a current induces in it. This incident is known as the electromagnetic induction. In this example, a wire is moving perpendicularly inside a magnetic field. Due to the movement, a current induced in it. In another case, this conducting coil is moving inside a changing magnetic field. And, for this movement, a current generates in it. Note that, whenever the conductor stops moving, the current vanishes. Now, the question is, which direction the induced current would follow? To understand this, we need Fleming's right-hand rule, for a straight conductor, like this. What is Fleming's right-hand rule? It says, if you stretch your thumb, index finger and middle finger, of your right arm, perpendicular to each other, like this, and, if the index finger shows the direction of the magnetic field, and your thumb shows the direction of the movement of the conductor, then, your middle finger would show you the direction of the induced current. In this example, the conducting wire is repeatedly moves upward and then downward, causing its induced current to change direction. Now, when the wire is moving upwards, we can compare the situation with a right hand. The index finger is aligned to magnetic field. The thumb showing the upward motion of the wire. Thus, the current should be along the middle finger. And, here it is. Again, if the wire goes downward, the right arm need to be adjusted. In this way. The index finger still showing the direction of the magnetic field, as before. Thumb is downward, showing the downward movement of the wire. Middle finger is now in the direction of the current. Now, let us review the dynamo. Look carefully. Two sides of this rectangular armature are responsible for producing current. This red arm and this blue arm. Other portions of this armature do not produce current, effectively. When this armature starts rotation, from 0-degree position, goes about 90-degree angular position. The red arm seems to move upward, and the blue arm looks like going downwards. Hold a right hand at red arm of the armature. The index finger is pointing the magnetic field. Thumb is showing the movement of the red arm at this moment, which is upward now. Therefore, a current will be induced in this arm, and its direction is towards middle finger, that is outward. To show current, in the blue arm of the armature, you need another right hand, but with a slight change in orientation. The index finger is along the magnetic field. Thumb shows the downward movement of the blue arm. Hence, the current will be inward. These two portions of the current combine together, and cause a flow of current throughout the loop. Note that, current is from blue arm to green arm to red arm, or BGR. When it rotate further, about 180 degree, become vertical, the current reduced to zero. That is, no current flows in this position, because, at this position, the red arm and the blue arm move parallel to the magnetic field. and Fleming's right-hand rule not applicable here. Again, when it passes 180-degree position, current restarts, but its direction is reversed now. In its previous position, between 0 degree to 180 degree, the current was from blue arm to green arm to red arm, that is BGR. But now, it is from red arm to green to blue, that is RGB. One can verify this direction by putting a right hand near the blue arm of the armature. Rotating further, the armature goes to 360-degree position, which is vertical again, and no current flows in this occasion, since the movements of the blue and red arms become parallel to the magnetic field. As it rotates further, a new cycle of rotation starts again, and it continues to produce current, then stops, then flows, again stops, again flows, and so on. To monitor direction of the current, let's put this indicator on the red arm. Let us assume that the current flowing in the red arm is positive, if it is flowing in this direction. With the help of this cone, you can easily check how and when the direction of the current changes. You can check this in graphical representation too. It starts from 0 degree and reaches a maximum value when angle is 90 degree. After that it reduces amount of current and goes 0 at 180 degree. Then it starts negative current, reaches maximum negative value at 270 degree, and finally, comes to 0 at 360 degree. And gets prepared for the next revolution. AC and DC dynamo. Dynamos are either AC or DC in accordance with the output of the armature current. If we remove the front portion of the armature and add two circular metallic rings to it, called the slip rings, connect both ends of the armature to these slip rings. These slip rings are so adjusted that they can rotate about the same axis of the armature. To collect current from these rotating slip rings, two carbon brushes are to be placed there. When the slip rings rotate, the brushes keep contact with the rings. Also, to show an output current, place a bulb and connect both ends of the carbon brushes to it. After connecting, the whole circuit may look like this. If armature rotates now, the induced current will lit the bulb. Note carefully how current changes its direction. At this position, the current in bulb is directed from red brush to blue brush. After some time, it is from blue brush to red brush. And then, it is red brush to blue brush again. So, it is an alternating current that flowing through the bulb. Look at the blue and red arms of the armature. Whichever arm nears the blue magnet, its current is outward, and the arm closer to the red magnet have an inward current. You can check this current with this graphical notation too. It is a sine curve. DC dynamo. To get a DC dynamo, remove the front portion of the armature and introduce two semicircular metal rings to it. These semicircular rings are called commutators. They are connected to each end of the armature. They are so oriented that they can rotate about the same axis. To extract current from these commutators, two carbon brushes are placed there. Brushes are placed very strategically. When the commutators rotate, each brush remains touch with one, and only one commutator at a time. There should not be any chance for a brush to get in touch with both the commutators simultaneously. To show you the output current, place a bulb there, and connect each end of the brushes to it. Now, the whole circuit will be like this. If armature rotates, a current will be induced in it. This current will flow from red arm to red commutator, then red brush, to the bulb, to blue brush, to blue commutator, to blue arm. After some time, when the red arm goes closer to the red magnet, the situation is different now. At this instant, current flows from blue arm to blue commutator, to red brush, to bulb, to blue brush, to red commutator to red arm. Note that, in both occasions, the output current is from red brush to blue brush. Thus output current does not change its direction. It is a DC current. Hence, it is a DC dynamo. Check this graphical representation of the output current. Difference between AC and DC dynamo. So, we observed that the two main difference between AC and DC dynamo is AC dynamo contains two slip rings, but DC dynamo does not. Instead, it has two semicircular commutators. Output current of AC dynamo is a sine curve and looks like this, while output of the DC dynamo is a repeated half sine curve and looks like this. Hope you realized dynamo and become able to answer any question related to it. Comment us if you find it difficult to understand. Like this video and support this channel to create better content for learners.